Welcome back to PiPlus Academy. Today, we're diving straight into something that's going to totally change how you see numbers, and it's all about ratio and proportion. We're going to break these concepts down into simple, highly visual pieces so that by the end of this explainer, you're going to feel like an absolute master of this math.
Here is our roadmap for today. 1. What exactly is a ratio? 2. Simplifying the ratio. 3. Seeing ratios out in real life. 4. Proportion and cross-multiplication. And 5. A little practice and summary to lock it all in. Let's get moving.
All right, part 1. What is a ratio? Understanding this core idea of how we compare quantities is the key to everything else we're going to do today. Picture this in your head. 3 perfectly crisp, bright red apples sitting on one side and 6 identical ones right across from them. When we talk about ratios, we're really just comparing two things of the exact same kind. We aren't comparing apples to oranges, right? We're comparing apples to apples. Since we have 3 on one side and 6 on the other, the ratio of these two groups is just 3 to 6.
Mathematically speaking, it's incredibly straightforward. A ratio is just your first quantity, a little colon symbol, and then your second quantity. For our apples, it's a 3, a colon, and a 6. And we always read that little colon symbol as is to. So if you were reading this out loud, you'd just say 3 is to 6. Seriously, it's that easy.
Moving right along to part 2, simplifying the ratio.
So, you've got your ratio, but sometimes those numbers are just a bit too bulky. It's kind of like cleaning up a messy room. Getting things into their simplest form just makes our mathematical lives so much better. Let's take the ratio 8 to 12. Step 1, find the highest common factor, or HCF. Basically, what's the biggest number that divides perfectly into both 8 and 12? That's going to be 4. Step 2, just divide both sides by that 4. 8 divided by 4 is 2. 12 divided by 4 is 3. And step 3, boom, there's your simplest form. 2 colon 3, or 2 is to 3. Finding that HCF really is your secret weapon here.
Which brings us to section 3, ratios in real life.
Because, let's be real, these aren't just numbers sitting on a test paper. Ratios are quite literally everywhere, bringing a sort of hidden, cinematic, mathematical harmony to the world around us. Think about it. We use ratios to compare the number of boys and girls in a classroom, books versus pens sitting on your desk, red and blue balls on a sports field. Even when you're just dividing up pizza slices at a weekend party, you're already using ratios every single day without even realizing it.
All right, buckle up for section 4, proportion and cross-multiplication. This is where things get really cool.
So, we've mastered the single ratio, but what happens when two totally different-looking ratios actually turn out to be exactly the same? Well, if we have 2 is to 4 on one side and 3 is to 6 on the other, when two equal ratios sit side by side like this, that right there forms a proportion. Even though the numbers themselves look totally different, the relationship between 2 and 4 is the exact same as 3 and 6. Both sides are basically just telling us 1/2.
And if you want to prove they're equal, there's this fantastic trick called cross-multiplication. It works like magic. You just multiply diagonally. So for step 2, take the 2 and multiply it by the 6, then take the 4 and multiply it by the 3. Step 3 shows us the big reveal. 12 equals 12. Because those match perfectly, we know for a total fact that this is a true proportion.
Let's try a solved example together. 3 is to 5 equals x is to 20. We've got a missing number here, represented by this mysterious x. It's like a math puzzle, but since we know that cross-multiplication trick, we are fully equipped to crack it.
Let's break it down. Step 1, hit it with that cross-multiplication. Multiply the 3 by the 20 and multiply the 5 by the x. Step 2, 3 times 20 gives us 60, so we get 60 equals 5x. Now we just want x all by its lonesome, so we divide that 60 by 5. Drum roll, please. Step 3, x equals 12. Just like that, you solved a real-deal algebraic proportion.
We're in the final stretch now. Section 5, practice and final summary. Time to test out these awesome new skills. Question 1, simplify 15 to 20. Remember, you're hunting for that highest common factor for both numbers. Go ahead and pause this explainer right now, grab some scratch paper, and work it out. I'll be right here waiting. And we're back. Let's see how you did. The answer is 3 to 4. Huge congrats to everyone who figured out that the HCF of 15 and 20 is 5. Divide them both by 5 and boom, 3 to 4. Awesome job.
Let's turn it up a notch for the next challenge. Question 2. Find x if 5 is to 8
equals x is to 24, a classic proportion mystery. Time to unleash that cross-multiplication magic trick we just learned. Pause the explainer, cross-multiply, and solve for x.
Ready? The answer is x equals 15. If you multiplied 5 by 24 to get 120 and set that equal to 8x, you probably knew you just had to divide 120 by 8, and that gives you 15. I've got to say, these are some seriously high-level concepts we're dealing with today, and you are absolutely crushing them.
Okay, one last dramatic test for you. Question 3. Check if 4 is to 6 equals 6 is to 9 forms a proportion. Are these two ratios truly equal? You know exactly how to prove it. Hit pause and run those numbers.
And the grand reveal? Yes, they absolutely form a proportion. Cross-multiply it. Take the outer numbers, 4 times 9, which is 36. Take the inner numbers, 6 times 6, which is also 36. 36 equals 36. It is a completely flawless proportion.
So let's lock this all in. The crucial points of everything we've done today basically boil down to 5 golden rules. 1. A ratio compares quantities. 2. Use that colon symbol to write it. 3. Simplify things down using your highest common factor. 4. Equal ratios equal a proportion. And 5. Use cross-multiplication to prove it. Master these, and this entire chapter is officially yours. Before we wrap up, I want to leave you with one final thought. Look around your room right now. How are you going to use ratios to compare things in your own home today? Maybe it's comparing the spoons to the forks in your kitchen or the windows to the doors in your living room. Math is quite literally everywhere once you start looking for it. Thank you so much for joining me today. If you found this explainer helpful, go ahead and give it a like, share it with your friends, and be sure to subscribe to PiPlus Academy so you never miss a thing. Keep exploring, and I'll catch you next time.